Hello students, today we'll talk about the latching and the holding current in power electronics. Um, what is latching current and holding current? Latching current and the holding current in the SCR. Latching current is the minimum anode current above which the anode current of a device must be increased in order to turn it on. That means if the device has to be turned on, then the current, anode current, should be greater than the minimum value of the current called as the latching current. The SCR gets latched. What does that mean? SCR getting latched means the very word latch implies that SCR is getting trapped into the conduction state. Once the anode current is greater than the latching current, you can remove the gate pulse. So you know that the SCR will continue to conduct once it turns on. So once the anode current is increased above a value called as the latching current, then it gets latched. That is why SCR is called as a latching device, because it gets trapped into the conduction. So once the anode current is greater than the latching current, you can remove the gate pulse. We can derive the minimum width of the gate pulse that is required to turn on the SCR for conduction state, after which you can remove the gate pulse. Then what is the holding current? Holding current is a minimum current below which the anode current must be reduced to turn off the SCR. So if the device is to be turned off, you just have to bring the anode current below the a value called as holding current. And SCR cannot be turned off through the gate terminal. Remember that. You want to turn off a thyristor, you reduce the anode current below a value. So this can be done by using an external commutation circuit which will reduce the IA below the holding current. So two currents we learnt. One is holding current, rather latching current, and the other one is holding current. If you want to turn off the SCR, it should be below the holding current. You want to turn on, it should be above the latching current. If the current is anyway below the latching current, it still remains in the off state, and if it is anything below the holding current, it is still in the off state. It will not turn above the holding current, it is turned on. Below the latching current, it is turned off. Above the latching current, it is turned on. What is TQ and TC? There's a difference between the device turn off time and the circuit turn off time. Time for which the SCR must remain in the reverse biased condition in order to remove the stored charges in the device is called as TQ. That is, TQ is the device turn off time. It will take some time, minimum time, during the reverse bias condition in order to remove the stored charges. So the total stored charges time, that is device turn off time, is equal to the recovery time as well as the gate recovery time. So that time it must be in the reverse bias condition. What is circuit turn off time? The time for which the device is kept reverse biased by an external circuit. This is the device, this is by the external circuit. So you see the TC is safety times that of TQ. Safety factor times TQ. Safety factor is generally greater than 1, usually of equal to 2. Generally, the device, rather circuit turn off time is always less than that of the device turn off time. Otherwise, if TC is less than TQ, the commutation failure or switching over, turning off will fail. If you want to commutate, rather the SCR has to be turned off. TC should be greater than TQ. Okay. So thanks for watching.